All right, so here's my plan for the day. We're going to keep working on the packet, and then I'm just gonna have time for you to like work on the homework and talk with your neighbors about it. Time to chat about the video if your group has questions or needs help with submitting it or anything, I'm here. Remember the video is due tonight. And don't forget, once you submit it, also make sure to fill out the feedback form. And that will contribute to your collaboration part of the grade. If you don't do it, then you'll get a 0 on that portion. So make sure you do it. From our like big plan talk last time, I've decided to postpone hashing and randomness just because I'm not a huge fan of the way that the textbook lays it out. So I'm gonna postpone it until maybe later. And then we'll go into graph traversals. That's the plan. So today we'll finish out divide and conquer, and the video is due tonight, and the homework for divide and conquer is due Tuesday night. Say that again? The packets, yes.
Thank you so much.
Does anybody else need a packet? Okay, let me come walk around. I've got a lot of packets, so. Okay. Okay. So last time we looked over how do we add things? How do we multiply? Just trying to break it down, write some pseudocode for it and try and reason about its complexity. Then we learned about where did I put those notes? I think they were on this one. Then we reasoned about how do we multiply numbers, and is there a better way to do it? One of the ways that there is a better way to do it is a method devised by a guy named Karatsuba, who wrote an O of n to the 1.6 algorithm, which is faster than n squared. And it's a divide and conquer algorithm where the focus is on breaking the numbers up into 4 parts, A, B, C, and D. And then in here, we only have to do 3 multiplications instead of 4. So we looked at these examples 1, 2, and 3, 4, 56, and 78. And then there was 83, 46, 29, 52, just for fun to practice that. And then we get into more, I guess, traditional divide and conquer questions, the first of which involved a circularly shifted array. The solution here is to use binary sort or binary search, where we try and figure out what's the biggest number in this if it's all sorted and it's just shifted around some. So as long as you have an attempt there, that's fine. So now I would like you to focus on problem 5 in your groups. So if you remember playing like 20 questions as a kid, where you think of, what is it, animal, vegetable, or mineral type thing, and then the other person asks you at most 20 questions to try and figure out what it is. This one is a numerical 20 questions where, given some number n, you think of a number in there and you've got 20 steps to try and narrow it down. And so to ask the fewest number of true false questions, yes or no questions, then they win. So this one's got two parts to it. First, what's the optimal strategy if you know what n is? This should be fairly simple. And then what's a good strategy, maybe not the optimal, but a good strategy if you don't know what n is. So talk about it.
Probably, I mean, you probably want to find that, right? Yeah, you guys know what it is, or at least you want to find what it is. You want to go above it, probably just go there like this. I also.
Yeah.
No, you can't put the use. Yeah, I mean, you also can't really ask, is it bigger? Back research, I don't know. Yeah, because it's true, false, right? I mean, well, I guess you could say. What is that? With this, you can obviously probably do the same. Just like, start with a small number, keep getting bigger.
Thanks for bringing that to my attention. Okay. What's the optimal strategy if we know n? I'm looking for two words here. Binary search. Because if we've got some array of numbers from 1 to n, and our number is somewhere in between them, then we can just use binary search to find that. If the number is absurdly large, is it still going to give us a number less than 20? This group will probably have an answer for me. If the number is really large, yeah. Yeah. So that's good to know that even if it's like 500 million or larger, then great. So in terms of a good strategy, if we don't know n, as I was walking around, I heard a few ideas. One of those ideas is looking at like getting the number of digits. And once you know the number of digits, then you can bound that number in some way. So like if it's 4 digits, then you know at most n could be 9,999 and so on. And then if you treat that as n, then you can just continue with binary search. Yeah.
Process. If you if you ask the person to convert it to hexadecimal.
They can only answer yes or no questions. I mean, you can convert any number to hexadecimal.
So, but. I mean, I think there's very.
Yeah. So then what would you do?
You did the same thing, but since it's a hexadecimal and it's less digits.
Okay. Yeah, so it's just a different phrasing of like number of digits in hex. So yeah, that might give us a slight speed up. Any of the other things to note for digits? Yeah,
Even the number of digits, do a binary search for each digit. Oh, 0.
the problem is, what if you have 5 million digits? Or 100 digits, or basically anything greater than 20 digits? Other thoughts? Okay. The other thing I was hearing is something with prime factors. Did you think more about that? Do you want to explain it?
So it's basically you kind of ask like, you go through the prime factors, like a segment. You just ask like, is the number prime factor of two, or what factor of prime number? And you keep on going. And since, just like, the prime factor, the prime number become more sparse as you put the process is that. It also like reduce more, like cut out more things at the beginning.
Let's see. So there's estimations. What if the number itself is prime?
Probably too. Potentially could be equal to, because if you do, you just look at the, the margin factor.
You'll eventually get there. Okay. I would need to be convinced that, so if we've got like a prime counting function, I would need to be convinced that that would give us something less than 20. Like, we got 20 guesses to see what this number is, and there's more than 20 primes. Yeah.
And like, it's a list of primes. Binary search.
Yeah. So yes, but you need to know the bound. So maybe you have like a combination of like, whoa, why did it do that? Maybe have a combination of like the number of digits and then like the next smallest prime and go through that way. That's a possibility. Binary search on list of primes. Okay. So those are two good approaches. There's also one on exponential search. Do you want to explain that?
Yeah, basically what exponential search does is that it can double the range of the target range, and basically once the desired range is basically found, it can do binary search, which works really well when if n could be a very large number. So in this case, if n is not known, it's something that we can apply to find it.
Right. So the idea is first try to find n by doing this exponential search of guessing powers of 2 larger and larger and larger. Then that gives you the bound. And then just do binary search. Yeah. Great. Any other ideas that didn't catch? Any other like category of strategy? Okay. So there's multiple ways to go about this. It's a difficult problem. All right. Let's move on to what I believe is the last problem. Yeah, it is the last problem on the packet. Which is, let's assume we're given some sticks. Each of them has integer length, so either they're one thing long or two things long, or maybe 500 things long. And we're given some list of the lengths. So if we've got a list like this, where we've got one that's 10 things long, another that's 6 things long, 5 and 3. So just the ith stick has length, the ith thing in the array. Our goal is to cut the sticks. So we want k pieces of exactly the same length. And we can have fragments. And so the goal is to maximize k. And yeah, maximize k and maximize the length. So k pieces, the number of pieces, and the length. So the example to start with is if we're given 4 sticks of lengths 10, 6, 5, and 3, what are the largest sized pieces? When we're asking about size, for if we have 4 sticks. How can we break these sticks up, have the largest size, and have 4 sticks total, plus fragments? Does anybody need clarification? Yeah.
Like, second top.
I think just cut. I don't think we have glue. It's not like in, I was playing Tears of the Kingdom last night, and it's not like we have Ultra Hand, like glue the things together. You can just cut. Yeah, question.
I think that's like, oh, fine.
We're given an array of lengths. And so, like the 0th stick has length 10. It's just, this is the set of stick lengths that we've got. Yeah. Make free linen fragments. Yeah, that's an option. I'm looking for clarification questions, and then we can, I'll let you talk about it amongst yourselves. Yeah.
How is it not 3? Because if you can only cut then.
I think there is an answer. Yeah. Yes. Yes. And you can can't add. So you can cut yes. We're trying to maximize the length of the stick. And here we're going to have 1, 2, 3, 4 sticks plus maybe some fragments. 4 sticks of the same length. Yeah. Clarifying question?
Alright, so. So the sticks, they start off with lengths, or they start off.
Yes, they start off with all of these lengths.
So
So, let's say I cut 10 in half. Would I get it?
Yeah. Okay, talk about it. Okay, do we have a consensus for the first question? What is the answer? Yeah,
We started to go about it by cutting off the 10 into two pieces, five, fives, and then cutting the inch off of the six. So then there is four, five.
and we've got an extra 3.
There's not, can be extra.
Oh, and also. Wait, sorry, say that last thing again. There can't be extras. No, there can be extras. Yeah. So,
Okay.
in addition to other fragments. So we can have like our 1 hanging out here, our 3 hanging out here, and those don't count towards our total. So we've got 5, 5, 5, 5, 4 pieces, k equals 4. Is that it? Could we do better? Consensus seems to be no. Okay. So now how do we prove that? Give me an algorithm. Okay, let's come back and talk about it. Thank you for engaging with this. It's a difficult question. There's some variations out there where like if you know K and you know the length, then maybe this is easy. But if you don't know the length, then maybe this is harder. So to kind of summarize what I was hearing as I go around, some people are talking about finding the average length. There was another group talking about maybe finding like the greatest common denominator in our list of lengths. Some strategies are to like split the biggest and then look for that length among the array. Another one is to like have some sort of weight, to assign weight to the lengths and try and reason that way. And then over here we had like start small and look for if this number divides all of those and if it gets you to the length. Does anybody have a working solution that they think they've got and want to share? Yeah.
So first said, sort the array largest to smallest. Then go to the k stick, or the smallest if k is greater than null. And then divide the length of all the sticks by the smallest stick and round down. Then add the results together and compare to k. If larger than k, go to the next largest stick and repeat. If the result is less than k, repeat the steps with. And yeah, so if the result is less than k, then that means you don't have enough, the size is too big. So you would repeat the steps with lengths derived by a binary search, with the last stick with the results greater than k as the minimum, and a stick with the result less than k as the max. And once you have a length where the result equals k, you would repeat the steps with the length increasing by 1 until it no longer works.
Mhm.
Then you have the maximum possible.
Yeah. So would this be like where would you categorize it on our ABCDE? Or is it a new category? Okay. Yeah. Okay, fair enough. Anybody else have a working solution? I would like to hear yours.
I was very linear and
Mm-hmm. Do you want to explain your linear version?
basically, the famous sorted array and start with the smallest value. So kind of like how like the 3 was in the last one.
Mm-hmm.
And then you could go through and see basically how many times you could split key values of alpha x of 1. How many times you can split make them divisible by that value. And then if it's greater than or equal to x, then you would say, okay, this is a possible high x value. Then you would go to the next. You would say, okay, does this one work? So that would be like 5. And if the 5 does work, then you would get rid of 3, you make a fragment. This would leave the array. So okay, now it's 5 is possible, like highest 6, and if 6 doesn't work, we can see if there's any values between those two, like whole numbers. So like if it wasn't 5, 6, 4 and 6, you would try out 5 to see if 5 works. That way you're making sure you're putting that values that aren't within the technical like, L that we are given, but that would still work.
And did you make any headway on the divide and conquer version?
I was just trying to look at it, like, trying to figure like, you would still maybe do the first value that you're given to see if you even have the value L that is within it that would work for that.
Mhm.
If it does, you go maybe to like half the biggest number or half of the sorting. So you would go, okay, if I have 10 values, what's like the fifth value, see if that one works, if it doesn't go between those two. Middle ground.
Cool. Anybody else have a working solution that they want to present? Okay, that's fine. Thank you for participating. So this is the end of the divide and conquer packet, so I think I'll make it due when the homework is due. So hang on to it, maybe work some more on it if you feel so led. And for the rest of the class, so let me save this. For the rest of the class, you can work with your neighbors or with other friends and work on homework 4 if you haven't gotten there already, or check in with your group about the video and see if there's anything to be done. And I'm here for questions. So the rest of the class is maybe group work if you want, but otherwise working on your deliverables.